Today's lesson is about least squares regression. Now this has two different names. I kind of introduced this line to you the other day with 10-2, but we're talking about the line of best fit or least squares regression line. The way it gets its name, least squares, is we're trying to minimize the square residuals that put your line in between your data, so that you are trying to minimize the distance between all of them so that it showcases that correlation that we're looking at. And so residuals are just the variation or the difference between what we observe and what we actually expect to happen. And then we'll be able to find something called a coefficient determination, which will allow us to take the square root of it, which is r squared, to help us find a correlation coefficient, which is the r. Okay, so let's go ahead and kind of jump into some of these. And so for example 1, this is an example from, I believe, 10-1, where we talked about dinner plates if you did it on your own. And so here's the graph with a line of best fit. Their correlation coefficient is 0.604. And so they would be able to find their regression line based on that and kind of the least squares. So the slope was 0.0128 and the y-intercept is negative 14.80. Okay, so here, if I move over to example 2 to kind of, how do I write my equation for this? So in order to find my equation for the line of best fit, I will use the equation that we have on the right, where your slope is equal to your r value, correlation coefficient, times the standard deviation of the y's, so the y values, divided by the standard deviation of the x values. So I get 0.2 times 1.5 divided by 4.7 here. That gives me 0.064. And then from that and a predicted value, that will allow me to find my y-intercept, which is a. And I'm sorry that they've mixed up the letters here, and I know it's usually m and b for the slope and the y-intercept, but this is what the book does, so I'm just following the same format so you don't get confused when you're looking at the equations and stuff like that. And so plugging in the 12 for y, the 6 for x, and our slope of b in for that part, I can solve for a here to get. Allows us to find the y-intercept at 12.4, and then I can plug that back in to find my regression line. So here I would like you to take a moment, stop the video, try letter B, see if you can do the same thing. Okay, and so letter B, your B value should be negative 0.08, your A value should be 4.63, and then that gives you your regression line equation. Now, they will also ask what would a predictive y value be given the x. So here, using the equation from above, if I plug in 3 into the regression line equation that I found, that allows me to find the expected value here of 12.19. Now you can round to the nearest tenth or the hundredth, whatever you want. So here, take a moment, pause your video, try letter B when the expected value is 24 for the previous one. So your expected value should be 2.71. Okay? So then moving on, now I've kind of talked about residuals. That's what minimizes that distance. So residuals is always going to be your observed value minus your predicted value. And so for example 4, you're given an observed value, so 70 is observed when x is 5. I would like to know what my predicted value is, so I need to plug in 5 just like we did for the previous example. And so plugging in 5 gets me the value of 62.724 or 5. And so in order to find my residual, I will take what I observed minus what I predicted to get the difference between the two, so 7.275. So if you would take a moment, stop the video, try letter B when your observed value is 8, 100, for the given regression line. Okay, and so taking a look at letter B, it looks like your predicted y value is 189.604. And so then when I subtract the 2, I should get a negative 89.604 as well. Now, if I want to find my coefficient of determination, that r squared, I will use the one on the right there. So the standard deviation of the y squared minus the standard deviation of the regression line. So my r's, my residual squared, divided by s of y squared again. So as I'm plugging them in, it's just 9.1 squared minus 8.17 squared divided by 9.1 squared to get me the value of 0.0859. And so if I want to find my correlation coefficient, I would just square root that value, which gives me 0.29 in this case. So pause the video, give it a try for letter B given the following values. And so here you should get the r squared value of 0.80, which gives you the correlation coefficient of 0.89. Okay? So hopefully that makes sense. Let me know if you need any help with anything. Go ahead and try example 6. It kind of works you through being able to do that with the applet to find said information. Okay? Have fun.